Hi everybody. In this segment right here we're going to kind of review and go back over the Titer counting that we did in class and serial dilutions. So if you remember correctly, the whole point of what we were trying to accomplish was to find out how many cells per milliliter of bacteria we were able to grow in this culture, trying to find cell density. And the way we did that was, first thing we did is we inoculated this flask. We have about 30 milliliters in here of LB broth, sterilized it one night, came back to class the next day, added our bacteria to it. We also found out in class from other labs that if we take this bacteria and we put it directly onto a petri dish, it's going to be a lawn, it's going to be like solid from one side to the other, and that's going to be something we can't really count. It's just too much bacteria, so that's we got to dilute it, and that process was serial dilution. So we took 7 tubes. Filled them with 9 milliliters of water because we're going to add 1 milliliter to the 9 later on, so we get to 10. So we're going to try to really work with ones and zeros that'll make our math a whole lot easier. So 9 milliliters of water, got that all sterilized. And then what we did is we used Big Blue and we transferred a milliliter of the cell concentrate into the first flask, mixed it around. And then we went from the first, not the first flask, the first culture tube to the second culture tube, and then from number 2 to number 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. And we could have kept going on basically indefinitely, dilute all the way down. But it comes a point where you're no longer diluting cells, you're just diluting water the farther on down the line you get. Experience has shown that about 7 minus 8 dilutions is plenty for working with bacteria. So after we got them diluted, then we went ahead and we used a different pipette. We took 100 microliters of our diluent and we put it onto our plate, and then we smeared, and then we used our hockey sticks and smeared it around and spread it on that plate. So we didn't do them all. Different groups did different ones. Each group was assigned just 2 of the 7, and between the class we were able to get them all done, and so we had lots of different plates to look at. So what I did right here is I plated out a -5 and I did a -6 dilution between the two, so we can take a look at that. So I've now have colonies growing on here, and I'm going to count them and do a little bit of math. Don't worry, the math is pretty easy. If you don't get frightened by the math, it's not a big deal. So I need 3 pieces of information before I leave the lab. 1, how many cells or colonies, one cell makes a colony. So how many colonies are growing on the plate? First thing I need. Second, how much did I put onto this plate to make those colonies? And I said this a minute ago probably. I used 100 microliters, which is a 0.1 milliliters of dilutant, of diluted cells to make that. And the third one, what is the dilution that I actually did use? And so I said I got a -5 and I got a -6. Got all the information I need. Number of cells, the dilution factor, and amount plated. All right, let's head on up front and we're going to go take a look on the smart board and do a couple of quick examples for you. So here we go. All right everybody, welcome back up front. Here we are, and so here's the numbers that we ended up pulling off of those plates. The first plate, we counted 38 colonies, 3 pieces of information. 38 colonies, 1/10 of a milliliter on my -5 plate. The formula I'm going to be using is this one. Cells per milliliter is equal to the number of cells counted, and cells counted make colonies. 1 cell makes a colony, so those equal to each other. The reciprocal of the dilution factor times the reciprocal of the amount plated will give me my cells per density, cells per milliliter in that flask. So when I plug in my numbers, I get 38 cells. I have the reciprocal of 1 times 10 to the -5, 1 divided by 0.1. Put it all together, 38 cells. Get ready for this part. Ready for it? Wait for it. 1 divided by 1 times 10 to the -5 is just to the 5th. Sign changes. Pretty slick trick. 1 divided by 0.1 is 10. That's handy. This is why, hopefully you're starting to see why in lab we were so careful to use numbers that all used 1s and 0s. So math works out super slick like this. All right. Take it a little farther. To the 5th times 10 takes me to the 6th. I'm going to multiply those together. 38 cells times 1 to the 6th. 38 to the 6th. Decimal's in the wrong place. Decimal belongs after the 3, not after the 8 for scientific notation. One place over. So I need to move it once. That's going to give me another place over here. So that takes me to 3.8 to the 7th cells per milliliter. Hard sometimes to relate to. What does that mean? To the 7th power. To put it in normal numbers, I'm going to back that off 7 places and backing off 7 places, and I get about 38 million cells that are inside my flask. That's a lot of cells that are inside that flask, and that makes me pretty happy that I got that number. So let's see if our second plate kind of corroborates that also. So second one, I only had 4 colonies on that. So far so good. I diluted it 1 more magnitude, so I should have less colonies on it, and I do. Good. Start the math part. Only 4 cells this time. The reciprocal's on the -6th plate, not the -5. 1/10 of a milliliter, 4. Change the sign. 10 milliliters on that. Multiply that together. I can get to the 7th right there. Now, the decimal's in the correct spot. So when I put that together, I don't have to move anything, so the decimal's already where I belong, so I'm going to stay at the 7th. And when I stay at the 7th, I get about 40 million, and that makes me feel good because the last slide I had 38 million. 38 million, 40 million, those are just basically about the same number. So this is how we go ahead and we figure out titer counting. I hope this is helpful, and I hope you'll enjoy doing this stuff in lab. It's pretty easy, and at the very least, good luck on the quiz.